Okay, so far we just figured out the size of the sample space. Now we need to look at our event, which is the event that each player gets an ace. Let's call that event A. In how many ways can that event happen? How many possible hands are there in which every player has exactly one ace? So I need to think about a sequential process by which I distribute the cards so that everybody gets exactly one ace, and then try to think in how many ways can that sequential process happen. So one way of making sure that everybody gets exactly one ace is the following. I take the 4 aces, and I distribute them randomly to the 4 players, but making sure that each one gets exactly one ace. In how many ways can that happen? I take the ace of spades, and I send it to a random person out of the 4. So there's 4 choices for this. Then I'm left with 3 aces to distribute. That person already got an ace. So I need to look, I take the next ace, and I give it to one of the 3 people remaining. So there's 3 choices for how to do that. And then for the next ace, there's 2 people who have not yet gotten an ace, and I give it randomly to one of them. So these are the possible ways of distributing for the 4 aces so that each person gets exactly one. It's actually the same as this problem, starting with a set of 4 things. In how many ways can I partition them into 4 subsets where the first set has one element, the second has one element, the third one has another element, and so on. So it agrees with that formula by giving us 4 factorial. Okay, so there are different ways of distributing the aces. And then there's different ways of distributing the remaining 48 cards. How many ways are there? Well, I have 48 cards that I'm going to distribute to 4 players by giving 12 cards to each one. It's exactly the same question as the one we had here, except that now it's 48 cards, 12 to each person. And that gives us this particular count. So putting all that together gives us the different ways that we can distribute the cards to the 4 players so that each one gets exactly one ace. The number of possible ways, it's going to be this 4 factorial, coming from here, times this number. This gives us the number of ways that the event of interest can happen. And then the denominator is the cardinality of our sample space, which is this number. So this looks like a horrible mess. It turns out that this expression does simplify to something really, really simple. And if you look at the textbook for this problem, you will see an alternative derivation that gives you a shortcut to the same numerical answer.